Voyager 1 recently detected 500 unidentified celestial objects as it continues its journey through space, potentially challenging previous notions and prompting a new understanding of the universe. The spacecraft's aging components, over 45 years old, have defied expectations by continuing to perform well, thanks in part to its duplicated computer systems and innovative power-saving measures using radioisotope thermoelectric generators, RTGs. Voyager 1's surprising findings, including the recent detection of celestial objects, have the potential to reshape our perspective on space exploration and the universe. Specific temperatures are essential for optimal performance. However, as power gradually decreases on the Voyager probes, saving energy becomes crucial, affecting various systems, including the spacecraft's heating system. Engineers must carefully balance power generation, temperature control, and operational requirements, as managing the spacecraft involves this delicate equilibrium. The spacecraft's engines play a critical role in adjusting and maintaining the spacecraft's direction, and fuel consumption must be carefully managed, as the loss of control could result if the fuel lines freeze. Additionally, the spacecraft's aging systems, including the main engines, pose risks, as evidenced by Voyager 1's engine trouble in 2017. To address potential issues with the main engines on Voyager 2, engineers plan to utilize the backup engines, which have been well maintained for future use. Notably, the backup engines on Voyager 2 have not been as dormant as Voyager 1's, having been quiet since Voyager 1's visit to Neptune in 1989. Furthermore, the careful management of power usage has allowed Voyager 1 to exceed its expected lifespan, enabling ongoing exploration and data transmission. As Voyager 1 moves farther from the Sun, adjustments to power usage must be made to optimize energy utilization. Despite the challenges posed by communication delays due to the spacecraft's distance from Earth, the mission team meticulously plans and executes communications and patiently awaits feedback. The recent anomaly, wherein Voyager 1 detected 500 celestial objects, further underscores the complexities involved in managing and interpreting data from the spacecraft. The anomaly, causing a brief delay in communication, was attributed to an old part of the spacecraft affecting data transmission. Confirming such discoveries from the distant spacecraft requires meticulous analysis and patience due to the significant communication delay. In conclusion, the ongoing management and operation of the Voyager spacecraft in deep space present numerous technical challenges, but through collaborative efforts, engineers and scientists strive to ensure the continued success of the mission while maximizing scientific data collection. Delicate like a computer part, it can break or mess up how data is sent. While these are some good explanations for what happened, there's another idea that has fascinated scientists. It's not about technical problems, but rather suggests the possibility of aliens being involved. Some people think that an incredibly advanced alien civilization with far superior technology than ours might have encountered Voyager. Since Voyager is super far from Earth and always seeking information, it's possible it ventured into an area where aliens reside, but we can't detect them. Instead of something going wrong, they might have taken control of it on purpose, which would explain the strange behavior. So, what we thought was a problem might actually be an amazing discovery. But if this really happened, how can we be sure? This question is a big one, especially when we're dealing with the vastness of space and the limitations of our technology and science. To figure this out, we need to understand how Voyager works. The spaceship uses NASA's Deep Space Network, DSN, to communicate with Earth. The network consists of 3 stations on Earth, each with a big 37-meter antenna that is effective at sending and receiving radio waves, especially the one pointed at Earth. Voyager 1 typically uses something called Deep Space Network Channel 18 to send important data back to Earth. It employs frequencies of 2.3 GHz or 8.4 GHz for sending data, and when we want to talk to Voyager, we use 2.1 GHz. If there's a moment when Voyager can't communicate with Earth directly, it has a digital tape recorder that can store about 67 megabytes of data and can send that data when communication is restored. Scientists can examine the data Voyager recorded during the time it was behaving strangely to see if there's any evidence of alien contact. Voyager 1 also has a variety of tools to collect detailed information, which are part of something called the Attitude and Articulation Control Subsystem. This system keeps the spacecraft steady and ensures its radio antenna is pointed directly at Earth. One of these tools is the Cosmic Ray Subsystem, which measures the strength and qualities of cosmic rays, providing essential data about space beyond our Sun's area. Another tool is the magnetometer, which carefully examines the power and direction of magnetic fields in space. Voyager 1's tools help us learn about space. For example, the photopolarimeter looks at light and informs us about space dust and other celestial phenomena. The plasma science instrument helps us study charged particles called plasma, providing insights into their quantity, temperature, and velocity. Tools such as the ultraviolet spectrometer measure the light from objects in space, while the infrared radiometer checks the temperature of celestial bodies. All of this assists us in learning more about space. In 1993, Voyager 1 and its companion, Voyager 2, made a significant discovery. They found the heliopause, which is the boundary between the solar wind and interstellar space. This boundary delineates where our solar system ends and interstellar space begins. When Voyager 1 visited Jupiter and Saturn, it made fascinating discoveries. At Jupiter, it observed a ring around the planet and 2 new moons, while at Saturn, it found 5 new moons and a new ring. These findings enhanced our understanding of these massive planets and their moons. One of the most astonishing discoveries made by Voyager 1 was on a moon called Io, which orbits Jupiter. It revealed active volcanoes on Io that ejected lava into the sky. These volcanoes occur due to the interactions between Jupiter and its moons, demonstrating the dynamic nature of outer space. Voyager 2, Voyager 1's companion, also provided valuable insights. It measured the termination shock, where the solar wind decelerates and becomes denser, marking the boundary where it meets interstellar space, the first mission to do so. Both Voyager missions enriched our knowledge of the solar system, providing detailed images and vital data about planets and their moons. In addition to this, there is the intriguing possibility that Voyager 1 might have encountered an alien presence. The data it transmitted regarding the detection of 500 unknown objects is truly compelling. Scientists will closely analyze this data to decipher its significance, and we eagerly await their findings to learn more about this remarkable discovery. If you enjoyed this video, please give it a thumbs up and subscribe for more interesting content. Thanks for watching.